Hello everyone, this is Professor Gant, and this is a video trying to explain what you need to do for the second LASA project for Math 109 or 109. And so the second assignment is about apportionment, okay? And part of the reason why we have these projects here is that since the classes are only 5 weeks long, there's really not enough time to be able to cover every single thing in the classroom with the time that we're given. If you're taking an on-campus class, or with the time that you're given to kind of cover everything. So some of these things, they didn't want to necessarily have you do a bunch of homework problems on it, but they wanted to give you a project to kind of encompass the spirit of what they want you to learn, because you still have to cover the same topic. So for this project, we're studying apportionment methods, and this is just basically how we decide to do things like if we want to have a committee, or a more realistic example, let's say the Senate or House of Representatives. We wanted to figure out, well, how many seats are we going to have, or how many people we're going to use to represent a particular country by, populations per state or whatnot. We have several different methods that we can use to do this, okay? And no one method is more fair than the other. It's just a matter of what you're willing to not have, okay? And so this project basically says that we're a census officer in a newly democratic nation, and we've been charged with using the census data from a table to determine how 100 congressional seats should be divided among 10 states. And so what we're given here is each state, and of course just by number, and we're given the population for these states. And so if we continue on, it says, being a fan of United States history, you are familiar with the many methods of apportionment applied to this problem to achieve fair representation in the U.S. House of Representatives. So, and of course, in your textbooks, this will be chapter 11, sections 1 through 4. If you are in my course, then if you look in your, I think it's module 4 or module 5 announcement area, or announcement that you should have received in your email. And if not that, you can look inside our virtual campus and get it. There is a link to some notes that I have, and I'm going to briefly show some of those on how we do these various apportionment calculations. And so you want to use that to your advantage here, okay? Now, out of all the apportionment methods that we speak of, we want to focus on the Hamilton method of apportionment, okay? And we want to use that to determine the number of seats each state should receive. Using these numbers that we just calculated here, we want to determine what's called the average constituency of a state. And we want to explain the decision-making process for allocating the remaining seats. We also want to calculate what's called the absolute and relative unfairness of this apportionment once we figure out, how many people are going to be representing all of our states, okay? How many people is going to be representing each state amongst all our states. So to help you sort of get through this, I have prepared an Excel document. And that Excel document basically does most of these calculations for you. I'm going to go through this so that you understand what the Excel file is trying to do, because what you will have to do is put in your numbers for this and extrapolate the information from that to be able to write your report, okay? So I'm trying to meet you halfway by at least preventing you from having to do a bunch of tedious calculations by just making an Excel file that kind of does most of that stuff for you. I'm more concerned about you knowing what the calculations are doing and being able to translate what the numbers actually mean, okay? Now, with that being said, I'm going to go ahead and pull up the Excel document here and kind of go through this process of what Hamilton's method is about, and then show you how this whole thing of calculating was the absolute and relative unfairness, as well as the average constituency, how that all comes into play. All right, so I now have the Excel file pulled up that you have access to. And so in looking here, if you're looking for this and you're in my course, then it's named MAT109_M5_ apportionment solutions class example. So here, these are the numbers that you will use. I am going to use numbers that are different, okay? And I'm going to go ahead and put these numbers here. So these would be the populations that we have here. Now notice that we need 100 congressional seats. So here we have 100 that I need to put right here, okay? Also notice that here we have this number, which is 256, and we'll kind of see where all that comes from, once we're done here, okay? So I am going to just make up some numbers here. And let's see. And make up a few more here. And this way too. See, I'm on 8. Yeah, so that one. I'm trying to get these numbers in the same relative range. So here we'll make this like that. We'll make this 55. That. And here 26,876. All right. So we've made up some numbers here, and what I want you to do is to understand what's actually happening when we make these calculations here, okay? Now, the first thing that needs to happen is that we have this number that's here, okay? And notice that this particular number is the total of all of our populations put together. So if we add up all 10 of these states' populations together, this is the total population, okay? And you can see that sum of cell B7 all the way to B16. So the first thing that we have to do is called a standard divisor. And standard divisor just basically says, hey, what's going to be the average population for each state, okay? If we just took this number, added all up, and divided by 10. So as you can see, if we take that divided by, in this case, 100, then of course you see that we end up getting the 5,854.76. And what that represents here, I think I misspoke earlier. So what this represents here is we're taking this total population divided by the number of seats. And so what that represents is, on average, each representative for this congressional organization here is going to be roughly representing about 5,855 people, okay? And so that's what the standard divisor is. Now, once we have the standard divisor, then of course what we need is the standard quota. And what the standard quota is we're taking whatever the population is for each state, and we're dividing it by the standard divisor, okay? So if we know that we have roughly 5,855 people that will be represented by one representative, then of course, if we have this number here, 10,345, then that's going to be roughly almost 2 representative should represent all these people. And so we're basically taking this and dividing it by this, and we get this number here. Now, if you can see, this is cell B7, this is cell I2, okay? So from here, we have our standard quota, and now what we need to calculate is the Hamilton number, okay? And so this is where the Hamilton's method comes along. So what we're doing here is we're taking this and we're going to multiply this cell here, which is C7, and we're going to multiply it times cell D1. Now you're asking, all right, well, here, yeah, I'm trying to read this to make sure that I'm telling you all right. So we got C7 and we're multiplying it by D1 and we're rounding the 2 decimal places, okay? So here, D1 is this cell here, which is the total number of seats that we have, okay? So we're basically saying, hey, take this, let me go back here, yeah. So take this cell C7, and of course, C7 is this one, the standard quota, multiply it times 100 so we can get the Hamilton number, okay? And so from that, we'll see that what we end up getting is basically this number here, okay? Now, the Hamilton number is its own thing, but how we actually figure out how we're going to I guess do the apportionment part is we're going to take this standard quota, and if you notice here, we're going to break this up into its whole parts and fractional parts. So these next 2 columns that you see here is basically this number broken up into 2 separate parts. So here, this is 1.7669, blah, 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 blah. You see we have the 1 here and we have the fractional part here. Now, the reason why we have that is because whenever we do this method, what we need to do is figure out how many representatives do we know for sure are going to represent this population here. And then based upon the fractional part, we figure out the pecking order of who gets the extra representative or not, okay? And of course, this 1 here, what this is called is the minimum quota. So that means we know at the least each state is going to have this many representatives. So for state 1, we know it's going to have 1 based upon this population. We know that for state 2, since it's 45,777 people, according to our standard quota here, we have at least 7 representatives that should be representing that particular state. And of course, we just go on down the line, okay? Now, if we keep going here, we see that when we add all these numbers up, we get 95, okay? So we know we have to have 100 seats, so that means we have to manually pick the other 5, okay? And so how we're going to pick them is by looking at the fractional parts here and saying based upon which fractional part is the most, we choose the first. Well, we add an additional seat to that state, and then so on and so forth. So for instance, if we're looking at these numbers here, I can tell you that the largest fractional part that we have here is this 0.871 number right here. So this means that state number 6 starts out with 16 representatives. We should give them an extra one, okay? All right, so now we have 4 more seats we need to fill. So 0.87 is the largest, so the next largest fractional part is 0.8187, that number. So we're going to go from having 7 representatives to 8. Because you had 7 here, now we have 8. The next largest fractional part, if I'm looking here, should be this 0.7724 number. So they will get an additional representative. After that, then of course, this 0.7669 number, next largest one, so they get an additional representative. And now the last one, I think should be, believe this one here, okay? So the 0.5904, so they should get an extra representative, okay? So we've taken care of the 5 extra remaining seats. Everyone else gets their own representatives, with the original set of representatives that they have from the minimum quota, okay? And so as you can see, we end up getting 100 as a result of that, which is exactly what we needed. Now, I want you to recognize something here, and I'm going to change these numbers slightly. Well, maybe I won't change them. So, but the point I want to make here is you see how we have the 0 here. So sometimes this happens. If the population is too small, you won't have any representatives. And so this is an extreme case of what the Alabama paradox is. And so an Alabama paradox is basically saying, hey, you may have had a representative before, but whenever we add to the population, you actually end up losing a seat because of that. Okay. Now, of course, this is the extreme case when you just don't have enough people to be able to do it. So here, what I'm going to do is I'm going to change this number here and go from here to, let's say, I will do, I'm just trying to make up something that'll be favorable here. All right, so in this case, it seems like we still don't have enough, so I'm going to do it like this. All right, so I'm going to erase this again. All right, so we're going to do the apportionment for this again. Now that we have all of these have at least one representative, and it's kind of like what these numbers are going to act like. So I'm trying to mimic that. So we'll go through this process again. The largest fractional part here looks like the 0.7294. So they'll get 2 representatives. And then the next one here is this 0.724. So they'll get 17. The next largest one looks like, oops, sorry. This one should have got 14 first. And then this one should have got the 17. So then after that, then the 0.653 number, they get an extra representative. And that's 4, and we just need 1 more. And I think the next largest fractional one is this one, so that would get 17. And then, of course, all the rest of them get their original minimum quota amounts. Make sure we did that right. That's 12, and then that's 15, and then that's 9, and then that's 4. And we still end up with 100 here. Okay. And I'm not sure why this particular number here. So, oh, okay, yeah, that's right. That's for something else. All right, so here we see that we have this apportionment here, and we're totally finished with that. So now we know state-wise how many representatives each state is going to have based upon that, okay? And so that part, as far as using the Hamilton's method here to determine the number of seats each state should have, that part is done. Okay, so here, I know for this particular cell here, this shouldn't be here. I believe this is like a mistake. Thought I was using this for something else, but I'm not. So I'm going to erase that. The think one of the issues that I had here is that I think I copied and pasted something, and this cell was incorrect, and it kind of dragged over into this one. So that's where that 256 was coming from. But anyway, I fixed it, and if you're in my course, then you'll have an updated file in your course here. So if you download this, by the time you look at this video, it should be already updated. So anyway, the next thing that we need to concentrate on is what the average constituency is. And so what the average constituency is, in general, it's just doing the ratio of the population of a state divided by the number of representatives from that state. So how we're getting this number here is we're basically taking, and I'm going to use state number 4 as an example. We're taking the population of state 4 and we're dividing it by the number of representatives that they have, okay? And so what this basically lets us know is how hard each representative is working, okay? So if we take this number divided by this number, we get this, 5,882. And of course, there may be some, rounding that we need to do with that. We just round to the nearest integer. So in this sense, we're saying that each one of these representatives is working for 5,882 people, okay? Now, if you notice here, we compare state 3 and state 4. Do you see how these populations here are about a little under 18,000 difference? But you see here that the average constituency is almost the same. So here, even though state number 3 has 17 representatives, these 17 representatives are working just as hard as these 14 representatives. So in all actuality here, we see that when we look at this, the state that has the lower population, they're working almost just as hard as a state that has a slightly bigger population. So we know that state number 4, the representatives from there are working almost, I would say, almost as hard as these, okay? Now, of course, state number 3 is working slightly harder than state number 4 because this number is larger than that one. But there's roughly about the same. So, and the reason I'm talking about this is because average constituency is sort of our segue calculation to get into what we call absolute and relative fairness, which is the calculations that I have down here, okay? So to review, we put in our population numbers for each state. Of course, when we do that, we get this total. And if we take this total divided by 100, we get the standard divisor. From that, we take the standard divisor and we say, all right, well, let's use the standard divisor and say each population divided by the standard divisor, that gives us a standard quota, okay? And of course, we calculated these Hamilton numbers here just to be able to do the Hamilton method. And of course, we got to do these calculations for that. So if we look here, if we take the whole part and fractional part and we sort of separate those, then we know that each member here, or sorry, each state has a minimum number of representatives. And so that's what's here in the minimum quota. And we look at the fractional part to see how we're going to assign the additional seating, okay? So here we just look at largest fractional part, gets the state that has the largest fractional part gets the first extra seat, second largest fractional part gets the next seat, so on and so forth until they're all gone. And so once we do that, we manually assign those 5 seats, and then we put in the minimum quota for the rest of them. And then, of course, our average constituency is just going to be whatever the state population is divided by the number of representatives that you have. All right, so before we move on to absolute unfairness and relative unfairness, just want to say here that for this Hamilton number calculation, I made this for something else I was using it for, and for this project, you don't necessarily need to use these numbers, but I do have the calculations in here, so you can just kind of ignore these numbers for what we're doing. All right, so what I want to bring in next is I want to bring in the notes that I have in our course so that I can kind of go over that average constituency thing again, and making sure that you understand where these calculations below come from, okay? So there is a document called Math 109 LASA 2 Help _ Unfairness Notes, okay? I'm going to show those to you and go to the page where we have the basic information that we need to calculate what we're going to be doing next here. So I'm going to bring these in and make this a little bigger here. So this is the start of these notes, understanding apportionment. And of course, apportionment is just a process of dividing up an appropriate and fair number of seats, rights, whatever, to several different groups, okay? You can go read through this. So basically what we did is the Hamilton's apportionment method is, we've already gone through that, so I'm not going to bore you with the details. But the next thing that we need to do is measure fairness. So in other words, how hard is one representative working versus another? And so here, when we measure that, one way that we do it is we say that the average constituency of state A is larger than average constituency of state B. Then that means state A is more poorly represented than state B. Or put another way, the person that is in state A is working harder than the person in state B. Okay, so we can use it that way. Now, like I've said before, average constituency is the population of a certain state divided by the number of representatives for that state. Okay, and here again, it just tells us how hard they're working. Now I'm going to move past this example because this is just an example of Hamilton's method, and we've already done that. So on this page, we talk about absolute versus relative unfairness. So what absolute unfairness is just the average constituency of a state minus the average constituency of another state, okay? And state A will always be the state that has the higher average constituency. So this number here will never be negative. So my point is, and I'm going to minimize this for a second, when we're making these calculations here, what this is just a table basically saying that, hey, I'm comparing, let's say here, state 1 with state 2, okay? And we see that here the absolute unfairness is going to be 550, okay? So that means the difference in between the average constituency of state 1 and state 2 is going to be 550, okay? Now, all these zeros that you see here, 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 and here, of course, that makes sense because when we compare a state to itself, its average constituency is going to be 0, okay? So there's really nothing to calculate there, okay? So we ignore what's going on with those zeros, but of course, like we said, comparing state 1 and state 2, absolute unfairness is just the difference in between the average constituencies, okay? And so this number here represents how many more people the state with the higher population, well, the state with the higher average constituency is working for compared to the state with the lower average constituency, okay? And what's down here, the relative unfairness, is the percentage of that change. And so if I looked here, what this is saying is that the representatives, whichever one has a higher population, I'll come up here and look at it. So here we know that state 2 has a higher population than state 1. Okay. So what that means here is that according to these average constituencies here, the difference, then we're saying that the representatives for state 2 are working about 10.63% more or harder than the representatives in state 1. Okay, so that's literally what that relative unfairness means. Now, bringing those notes back up, how we actually calculate relative relative unfairness, or in this case, relative fairness, as I have it in here. We take whatever the absolute fairness is, and we divide that by the smaller average constituency of state A and state B. Okay, so to make sure that you understand that calculation here, I have an example of what that would look like. So here, let's say average constituency of Wisconsin is this number, average constituency of Texas is this number. So, of course, Wisconsin has a higher average constituency, which means that the representatives in Wisconsin are working harder than the representatives in Texas. And the absolute unfairness is just the difference in between these two numbers, which is 13,406. And the relative unfairness will actually end up being whatever the absolute unfairness is, which is just 13,406, divided by the smaller of the two average constituencies, which is going to be the one for Texas. And so we see here in this example here that the relative unfairness is about at 2%. So that means that the representatives in Wisconsin are working about 2% harder than the ones that are in Texas. Or put another way, the representatives in Texas are working 2% less than the ones that are in Wisconsin. And so my point here is that when we do these calculations here for this particular table, that's all we're doing. We're taking the average constituency for each state, comparing state 1 to state 2, state 3, state 4, state 5, all the way to state 10. And we're doing an absolute unfairness and just dividing it by the smaller of the average constituencies to get these numbers here. And so once you do about one or two of these, then of course you can just copy and paste and do the rest of them. And so that's how I made this. So all you need to do now is once you have these numbers filled in here, all you need to do is these numbers will automatically populate, and all you need to do is understand what these numbers mean. Okay. Now, with that being said, in your report, what I am expecting you to do is to not only give me this Excel file as a means of your calculations, but I must see that you actually made at least one or two absolute unfairness calculations and one or two relative unfair calculations, so that I know that even though you had the spreadsheet, you understand how you actually got this number here, or how you got this number, and how this particular number, if we're comparing the relative unfairness of state 4 versus, let's say, state 7 here, which would be here, we want to know 148, state 4 to state 7. I want to know that you know how to calculate that number and what it means. Okay. And so I'm telling you that I'm looking for that in the report. So if I do not see at least one or two examples of you comparing two states to calculate its absolute unfairness as well as relative unfairness, I will not be able to give you full credit for the project. So just letting you know that straight up. So please make sure that in addition to all the other work that you do, that you use what I've given you here, and you make sure that you understand what these numbers mean and how to calculate these numbers. Okay. All right. So with that being said, all you really need to do is once these calculations are done, just put your, just write a paragraph or two, sort of explaining the process that you've done. And of course, in those 1 or 2 paragraphs, you can talk about how you calculated absolute and relative unfairness to show how we get, some of these numbers here. And for that project, that's all you really need to do. Okay. So as you can see, I've gone through this and basically have done a good portion of the calculating part for you. I just need you to understand what's going on here and communicate that in your report and give me some sample calculations here, okay? So I need sample calculations of absolute unfairness, relative unfairness, and if you can give me uh, an example of, well, I guess when you show these calculations here, I already know how you apportioned everything. But if you can give me an example of how you calculated the standard divisor, how you came up with standard quota, minimum quota for one of the states, that would be awesome as well. And so with that, that does conclude my explanation of how to do the second project. Again, I hope that this Excel file and this explanation helps. And if you do everything I ask, you should have no problem receiving full credit.